Alright guys, this is 082720. This is our new lesson, the definition of the derivative. Definition of the derivative. Okay, let me start by putting the formula for the slope, which is m equals y2 minus y1 over x2 minus x1. And then remember that m means slope. Okay, the same thing, derivative means slope. Okay, so if you think about it, if you have a function that looks like this and you pick 2 points, we can call this x1, we can call this x2, and if this is x1, the y coordinate would be y1, and this is x2, the y coordinate will be y2. So that's how we get y2 minus y1 over x2 minus x1. That's how you get the slope, which would be this. Okay? Now, let me put in calculus, they do it a little bit different. So, let me show you. So we have exactly the same function. You have the same 2 points, but then they call this x1, and then this one they call it x1 plus h. Remember how we said the limit should be really close? Okay, so these 2 points, so this is like x1 plus a little bit. So this would be just a little bit. So x1 plus h, so this would be h here. Okay, so it's just a little bit. Okay, so then our y coordinate, because this is a function, this would be f of x1, and then this would be f of x1 plus h. Okay, and it's exactly the same thing. Cool. So just picture that you have a function that goes like this. So remember how these are super close? So that will give you a super close slope of a point in a curve. So that's the derivative. So instead of writing it like this, we write it the limit as h approaches 0 of f of x plus 1, f of x1 plus h minus f of x1 all over h. So now look, y2 is the top, which is f of x1 plus h. y1 is the bottom, so this would be f of x. And then the bottom, you would say, well, what happened? This was x2 minus x1, and here you only have h. Well, this is what happens, look. So here you have x2. What is our x2? Is this x1 plus h. So when you have x1 plus h, and then minus x1, what happens to x1 minus x1? They cancel out, and you end up with h. That's why we only have h on the bottom. Okay? So this is the definition of the derivative. Okay? Cool. So let's do example 1. So example 1 says find the slope of the curve f of x equals x squared at the point 2, 4. Okay, so what I like to do is I always start writing the formula. I don't put the limit because it's gonna take time, and then I take the little one away from it. So I just put f of x plus h minus f of x over h, and this is easier to memorize. So now this is where it gets a little confusing, and well, people get confused. So look, so this is saying basically the function of x plus h. our function is x squared. This is our function, x squared. So they're saying, look, instead of plugging in any number, you're going to plug in x plus h inside your function instead of x. So our x would become this, and then you still have a square, so you put it here. Okay? So instead of f of x plus h, we're going to put x plus h quantity squared minus f of x. So f of x is just x squared. F of x is x squared, so you put it here. And then the denominator is just h. Okay? So again, this is telling you in your function, plug in x plus h. So our function here is x squared. So I'm going to open a parenthesis, put x plus h, and then you still have a square, so you square it. And then minus f of x. What is f of x? Well, x squared. And then the denominator stays the same. Now here, we have to simplify this. So that means that x plus h squared becomes x plus h times x plus h, right? The square means 2. So we simplify. So x squared plus xh plus xh is the same thing, and then plus h squared. That's the top. So instead of writing this, I'm going to write this. So I have x squared plus, this go together, 2xh plus h squared, and then I still have a minus x squared, and then don't forget the h and the bottom. And then you simplify a little bit more. Look, you have an x squared, you have a negative x squared, positive and negative, they cancel out. Now you have 2xh plus h squared over h. So here I have an h and I have another h here that I can take out. So can you guys see? Yeah. So I'm gonna say h and then whatever I have inside. So in this case I have 2x plus, so h times what gives me h squared? Well, h, and then I have another h on the bottom. Okay, I just took out an h and put it outside. So what happens? Top and bottom cancel out. So now I end up with 2x plus h. Now remember, so in the definition of the derivative is we're taking the limit as h approaches 0. So that means that this h we turn it into a 0. So because it's just 0, it goes away. So our answer would be 2x. Okay? So basically this is the slope of the curve x squared at the point 2, 4. And that's it. Cool? Okay, let's do another one. I think I'm gonna need, well, I'm gonna do it here. Example 2. Let's see. Okay, so example 2 says find, I'm just gonna put I'm just gonna put der for derivative. Find the derivative. Wait, let me do another one. Okay, I have one. So find the derivative of f of x equals 5x at x equals 3. Okay, so again, the first thing we're gonna do is copy the formula, f of x plus h minus f of x over h. The reason why I copy the formula for every problem is because you have to memorize it. Okay, and then I plug in. Remember, this is telling you in the function you're gonna copy, instead of the x, Every time you have an x, you're going to copy this. So here I have a 5 and I have an x. So I'm going to say 5. I'm going to open the parentheses. And instead of x, I'm going to put x plus h. 5x plus h minus, what is f of x? What is 5x? 5x. And then all over h. Again, we have to simplify this. You have a 5 on the outside, so you have to distribute it. So you're going to have 5x plus 5h minus 5x. And then the denominator stays. Look, this one is easy. You have a negative 5x, you have a positive 5x. They cancel out. So we end up with 5h over h. So what happens to the h's? Top and bottom, they cancel out. So the slope would be 5. Piece of cake, right? Let's do a more fun one. Example 3. Let's do... Let me do this one. Again, find derivative of f of x equals, I have 5x squared at x equals 1. Okay? So, f of x plus h minus f of x over h. Instead of x plus h, instead of my x squared, I'm going to put this. So I have a 5, open parentheses, x squared would be x plus h quantity squared, minus f of x, which is this thing, 5x squared, over h. So again, I have to simplify this. Let me do it on the side. Don't forget you have a 5. So you're going to put x plus h times x plus h. And we should already know that this becomes x squared plus 2xh plus h squared. And then you have a 5. So this would become 5x squared plus 10xh plus 5h squared. So this is just this part right here. So let me write it. 5x squared, then plus 10xh plus 5h squared, and then I have a negative 5x squared minus 5x squared, and then all this over h. Okay, so we simplify or combine like terms. Negative 5x squared, positive 5x squared, they cancel out, and now I have 10xh plus 5h squared over h. Okay, look, I have h, I have h. You can even take out a 5. Does it really matter? No, because there's nothing to cancel. Okay, so we're just gonna leave it like that. So I'm gonna take out an h, so I have 10x plus 5h, and then over h. Okay, top and bottom cancel out, so I end up with 10x plus 5h, and then remember the h is 0, so this goes away, so our answer will be 10x. Okay, now if they're asking just for the slope, this will be the slope. But if they actually want a number, so you would actually plug in x equals 1. So this would be 10 times 1. So the slope would be 10. Cool. Let's do another one. Example 4. Let me do one that is a little bit more fun to do. Okay, I have this one. So again, find the derivative. I'm just gonna put the function f of x equals x squared plus x. Okay, look, so if they give you the x equals, you have to plug in. In this case, they didn't give us the x, so we just leave it like that. So we don't have to plug in. So the answer would be the last thing we get. Okay, so again, f of x plus h minus f of x all over h. And then this is going to be fun because you have two terms that have x's. So the first one here, so x squared would be x plus h quantity squared, which we know is going to be x squared plus 2xh plus h squared. So that's this right here, this one. And then you would have plus x, so you have to plug in this again. So plus x plus h. Okay? So look, remember they're telling us, okay, so you see this, you're gonna plug it in wherever you have an x. So you plug it in here, and then you also plug it in here. So that's the first part. So let me write it. So I'm gonna have x squared plus 2xh plus h squared, and then I still have plus x plus h. So that's the whole thing. And then minus f of x. What is f of x? Well, it's this thing here altogether. So minus, oh, but we have to be careful because since it's a minus sign, you have to put it in parentheses because you have two terms. That means that you will have to distribute the minus. Okay? So this is going to be, let me just rewrite it. X squared plus 2xh plus h squared plus x plus h minus x squared minus x. That's what I did right here. I distribute the negative all over h. Okay? It seems like it's a lot, but it's just algebra, just pure algebra. This is x squared, negative x squared, they cancel out. I have 2xh, h squared. Look, I have a plus x, a minus x, they cancel out. H, that's it. So now I have 2xh plus h squared plus h all over h. See, look, if you already figured out, our goal, like here, is to factor out an h so you can cancel the h's, okay? So if you get to this point and you cannot factor an h, then that means you did something wrong and you have to go back and double check your work. Here, I have an h, I have an h, I have an h, so I can take out an h. So if I take out an h, this becomes 2x, I have a plus, this becomes h, and this becomes 1, right? H times 1 is h, and then I have an h on the bottom. Top and bottom cancel out, so now I have 2x plus h plus 1. And then remember this is 0, as h approaches 0, so our answer would be 2x plus 1. What's up with it? Cool? You guys want to do another one? Or you're good? Let me see. This one looks fun. Okay, let me get another paper. I'll get this one here. Okay, I want to do a hard one. Let's do this one. This would be example 4. F of x equals 1 over x. Again, same thing. F of x plus h minus f of x over h. Instead of your x, you're going to plug in this. So this becomes 1 over x plus h, and then minus 1 over x all over h. Okay, remember, f of x plus h, that means plug in x plus h in your x. Okay, so I have a 1, instead of x I plug in this, x plus h, minus, instead of f of x I'm going to write 1 over x, and I have an h on the bottom. The formula has the h. Okay, so now we have to simplify this, put it together. How do we do that? Okay, to add two fractions you have to have the same denominator. So that means that this one here needs an x. Whatever you do to the bottom, you do to the top. And this one here needs an x plus h. So I have x plus h. And again, whatever you do to the bottom, you do to the top. So you're multiplying x plus h. So now this becomes x at the top minus, when you multiply this, it's going to become, so the negative is going to be negative x, negative h, negative x, negative h, and then you can put the denominators together because they have the same denominator. Let's leave it like this to see what happens. So we just leave it like this, x times x plus h, and then you have an h. Okay, now look, if you have a fraction over a denominator, you can just put the denominators right next to each other. What am I saying? Let me give you another example. Let's say that I have 2 over 5 over 7. Okay? So what we do when we want to simplify something like this, we put a 1 on the big denominator, and then we multiply it times the reciprocal. Whatever you do to the bottom, you do to the top. Okay? So now I have, what happens here? They cancel out. So you end up with 2 over 5 times 1 over 7. So if you think about it, let me rewrite the problem so you can see what I'm telling you. So 2 over 5 over 7. Look, if we get rid of this 1, because it's just 1, you have a 2, you have a 5, and the 5 multiplies the 7. You have a 2, you have a 5, and the 5 multiplies the 7. So that's how I know that I can just do this. Okay? This only works if you have a fraction over a denominator. A fraction over a denominator. So like I did here, I brought the 7 up next to the 5. I can bring the h up next to the x. So this is going to become x minus h, x plus h. Okay? So let's see what happens here. X minus x, that gives us negative h. And then I have h, x plus h. This is a multiplication, so I can cancel this. So I end up with negative 1 over x. And then I have x. And then remember that h is 0. So I'm just going to put 0 here. Well, what happens to 0? It cancels out. So now I have negative 1. And then x times x is x squared. Isn't that fun? Okay, let me see. Do we have another fun? Give me 1 second, let me check. I think that those would be the most difficult ones. Let me do one with a radical. Example 5. I'm gonna choose, oh, this one looks fun. F of x. By the way, when I say this one looks fun, you already know what it means, right? Look at this one. 5 times the square root of 2x. Oh, and this one is saying at x equals 8. Alright, so again, we start with the formula, f of x plus h. This is called, again, the definition of the derivative, minus f of x over h. And then we plug in. Instead of f of x plus h, we're going to copy this. 5 square root 2. Instead of the x, you put x plus h minus f of x, which is this thing, over h. Okay? This is a lesson where my students always say, I don't get it, I don't get it, I don't get it. Look, this is telling you, in your function, instead of your x, you're basically plugging this in every time you see an x. You see the x here? Okay, so instead of writing this, instead of writing the 2 times x, you're gonna put this. So I put the 5, I put the radical, I put the 2, instead of my x, I put x plus h. So I'm done with that part right there. I have a minus, and then they're just saying, okay, copy f of x. Okay, f of x is that. So you write it, and then there's an h on the bottom. Okay, and then we simplify. Uh-oh, how do we do this? This is interesting. So remember, our goal is to take the h, so we have one h here, so we need to take it out. Interesting. What about if we square everything? Can I square everything? Let's try it. Oh, I know what to do. You see, this is something minus something. Remember the difference of two perfect squares? So this, if you have x squared minus 4, is the same thing as having x minus 2, x plus 2, the difference of two perfect squares. Okay, so we can flip this around. Because we have one with a minus, we put one with a plus, and then it becomes that. Let's see if that works. So I'm gonna put it in parentheses, and then I'm gonna copy exactly the same thing. 5 and then square root of x plus h, and then instead of the minus I write a plus. 5 square root of 2x. But remember, whatever you do to the bottom, you have to do to the top. In this case, whatever you do to the top, you have to do to the bottom, so I have to copy it here. And then plus 5 2x. Alright. So now here, when you square this, you're gonna get something like this. Let me do it on this side. I have 5 square root of 2x plus h squared. So this becomes 25, and the radical and the 2, they cancel out. So you have 2 and then x plus h. So this becomes 50x plus 50h. That's what you have at the top. Okay, so 50x plus 50h, I'm sorry, h. And then we will do the same thing to the other one. So the other one will be 5 square root of 2x quantity squared. That will be 25 times 2x, because this cancels. So that's 50x. minus 50x all over h. Okay? And then you have this on the bottom. I forgot a 2 here. There's a 2 here, and there's a 2 here. Right? Okay, well, let's see what happens. I don't know if it's gonna work, but it's okay. That's how you learn. So this is 2x plus h, and then plus, put a parenthesis here, plus 5, and then 2x. Okay? So just so we don't get confused, I'm gonna put this line here. Okay, look, simplifying, negative 50x, 50x, so now I have 50h, and then on the bottom, I have h, and then I have this whole thing, 5 square root of 2 x plus h plus 5 square root of 2x. Okay? Remember our goal is to cancel this out, so we're good. So now you have 50, and then we just copy the whole thing. So 5 square root of 2 x plus h plus 5 square root of 2x. So this would actually be the derivative. The cool thing about this is they're telling us at x equals 8. What does that mean? Instead of my x, I'm going to plug in. Remember that the h, because this is the limit, that's going to go away to 0. So I just plug in. So now I have 50, and then I have 5 square root of 2 times 8, that's the number that they want us to write, plus 5 times the square root of 2 times 8. Okay? Let me go on this side. The top is just 50. 2 times 8 is 16. Square root of 16 is 4. 5 times 4 is 20. 2 times 8 is 16. Square root of 16 is 4. 5 times 4 is 20. So this becomes 50 over 40, which is just 5 over 4. Cool. You know what? Let me check the answer just so I'm sure that we did it right. This was 5 to x, 5 to x, number 11. Okay, give me 1 second. Number 11. 1 second, guys. Number 11. What do you think? Yes or no? Yeah, we got it right. Cool. This is one of the most difficult problems that I've seen in doing this. So if you understand what we did here, we should be fine. The only problem that a lot of people have in this type of problems is understanding this. Remember, this is called a difference of perfect squares. If you have this number square and a minus sign and this number square, that means can you take the square root? Yes. So this becomes the first one minus the square root of the second one. So the square root of this one minus the square root of this one. And then again the square root of this one plus the square root of this one. Okay? And you can do it both ways. So if they're telling you, can you please multiply this? Yeah, so when you multiply it, you get x squared minus 4. Okay? So you have to learn how to how to identify that here. See, I don't know if you remember when I started doing this problem, I said, interesting. Because remember we said that our goal is this, cancel our h's. But in right here, the h is inside the radical. There's no way you can take it out. So anytime the h is inside the radical, we need to get rid of the radical first. So that's how I said, okay, so I have two terms on a minus. That's this here is basically this. this. So that's what I have. Something minus something else. So what I can do is put the same thing. You see how here you have x and you have a 2. So the only difference is the minus and the plus. So look, this is the same thing. Minus plus and then same thing. So now when you put it together, I multiplied it here. So you get this. So that's how you cancel the radicals. Okay? The only thing that you have to remember is that this was the original problem. Just this. So I added this. I multiplied this at the top. Remember, whatever you do to the numerator, you have to do on the denominator, or vice versa. If you put something in the bottom, you put something in the top. Mister, what do you mean by that? Okay. You have a fraction. 2/3. Can I multiply this by 4? Okay. If you multiply this by 4, you have to multiply this by 4. What do you get? 2 times 4 is 8. 3 times 4 is 12. Is it the same thing? Yeah, because this when you simplify it, half of 8 is 4, half of 12 is 6, half of 4 is 2, half of 6 is 3. You end up with the same thing. Okay? So whatever you want to do, you want to multiply times something, you do it top and bottom. You want to divide by something, you do it top and bottom. Another one, 10 divided by 15. Oh, I want to divide the 10 by 5. Okay? 10 divided by 5. If you divided the top by 5, you have to divide the bottom by 5. Okay? So this will be 10 divided by 5 is what? 2. And then 15 divided by 5 is 3. Okay? Is it the same thing? Yeah. Half of 10 is 5. No, that's not going to work. This is 10 is the same thing as 5 times 2, and 15 is 5 times 3. Same number, top and bottom cancel out, so you end up with 2/3, which is the same thing. You see, so you can multiply times something, or you can divide times something, and you still get the same thing. That's what I did here. I have this, let me multiply times, instead of the negative, you put the positive, same thing on the bottom. And then the rest is just simplifying. Cool? Okay, so I'm gonna post the link for your assignment. If you have any questions, let me know. Peace out.